What's poppin', dogs? Mr. Allen here with some SAT math prep focused on quadratic functions in this video. I've got a few different examples for you guys to go over, so let's get it started with the first one. I've got the quadratic function h is defined as shown. In the xy plane, the graph of y equals h of x intersects the x-axis at the points 0, 0, and t0, where t is a constant. What's the value of t? So really all they're asking you to do is just solve for x or find the x-intercepts, okay? So how do we do that with quadratics? Well, really with any function, if we want to know where it crosses the x-axis, my x-intercepts, we're going to set it equal to 0. So let's do that. I'll take 0 equals, and then we got 2 parentheses, x minus 4 quantity squared minus 32. So a lot of times with these standardized tests, they have a lot of fancy wording for some relatively easy math that you've done before, but there are different ways to solve a quadratic like this. My preferred method is to use square roots because I have a quantity squared, real easy to take the square root on both sides once we get rid of these two things over here that are with the squared part. You can also multiply this out, x minus 4 times x minus 4, distribute, combine like terms, that sounds terrible. I'm not going to do that. I'm going to add 32. That's the route I'm going to go here, okay? So we got 32 equals 2 parentheses x minus 4 squared. Then I'll divide by 2 on both sides. So we got 16 equals x minus 4 squared. And now I can square root on both sides to cancel out that squared, right? Square root and squared, they undo each other. What's the square root of 16? Well, it's 4. But when you are solving using square roots, there are two solutions there, right? We're going to get plus or minus 4. So we have, I'm going to swap things around now. X minus 4 equals plus or minus 4. Now, it might be a little bit easier to see this as x minus 4 equals 4 and x minus 4 equals negative 4. And if you already know your answer right now, just pop it in, right? We're good. But I'm just showing you guys the full explanation here. I'm going to add 4 over here. We get 8. Obviously, that's the answer right now. We got D. Choice D is my answer for this one. But then over here, you're going to see that we do get, when I add 4, I get 0, which is the other one they said, right? 0, 0, and 8, comma 0. So T is 8. That's it for that one. All right, beautiful. So if you see a quantity squared, square roots are generally the most efficient way to solve something like this, and efficiency is honestly the most important thing when it comes to these exams because you are pressed for time. All right, next question. So we have, what is the minimum value of the given function f of x equals x squared minus 48x plus 2,304? Holy cow, it's a big old number. So they give you these large numbers here, so it's a little bit trickier to plug it in your graphing calculator and find that minimum value. I'm going to show how to do that in another video that's focused on some different ways to use this calculator. For this one, I'm going to use a formula here, which gets us our axis of symmetry, which is the x-coordinate of our vertex, which we can plug back in to get the y-coordinate, which is our minimum value. So that formula is x equals the opposite of b over 2a. So what are a and b? Well, those are my coefficients, a, b, and c, of the form. It's y equals ax squared plus bx plus c. That's our standard quadratic form. So if I throw that into my formula here, to do that, I'm going to have x equals the opposite of b, which is negative 48. So negative 48 over 2a, so 2 times 1. You could actually probably do this by hand. We got positive 48 over 2 is 24. So x equals 24. That's not my minimum value. Okay, that's my x value when the minimum is occurring. So what we can do is we can plug this back in to get my y value. So I'm going to do 24 squared minus 48 times 24 plus 2,304, and we'll get 1,728. So here's what we did. We plugged in 24 to all of those values, right? We had 24 squared minus 48 times 24, and then we had plus 2,304. So we end up getting 1,728 as my final answer. And this is a free response problem, so you're going to have to just type that in or whatever on your computer there, but 1,728. And again, guys, I'm going to show in another video how you could graph it in here and efficiently adjust your window so you could see that minimum in case you don't remember this formula and the secondary process here to finish this one up. But that's about it for this one. Finding our minimum values, essentially what's your y coordinate of your vertex. All right, next problem. All right, a similar problem here asking for the minimum. It says the function f is defined by the given equation. For what value of x does f of x reach its minimum? So this time it is asking for the x value. For what value of x does it reach a minimum, rather than the y value, which is the minimum value. Well, how do we do this? This one's actually super duper quick and easy. If I take each factor, x minus 44, set it equal to 0, I get x equals 44. And then if I do x minus 46 equals 0, I get x equals 46. Now, if you think about your x-intercepts, let me just do a rough sketch right here. XY coordinate plane, it's doing something like this, okay? So it's going to be like, woo, and this is 44, and this is 46. Well, where's my vertex going to be? Smack dab in the middle at 45. So my choice is B right there. That's cool. You should be done with that one in like 10 seconds. If you recognize the factored form, gives you your x-intercepts, the vertex is going to be smack dab in the middle. The axis of symmetry is right in the middle there, and your vertex lies on it. So real quick one there, gain you some time for some more difficult problems. All right, last one for you guys here in this video. Thanks for watching this whole thing. Be sure to stick around for some other SAT prep videos that I got, or if you're taking the ACT as well, I do have a playlist dedicated to the ACT math section, which is actually a bit different from the SAT. So make sure you are studying independently for those two different tests. All right, the given equation relates the value of x and its corresponding value of p of x for the function p. What is the minimum value of the function p? So a lot of these different questions here, but they're all in different forms. And I've got this p of x equals, p of x plus 57. Interesting. That's kind of weird right there, right? To have the p of x not by itself equals x squared. Well, what if I just rewrite it, right? Like what if I just did p of x equals x squared minus 57? Now, if you know your quadratics decently, okay, you'll know that I have this point 57 right down here. So this is at negative 57, right? Or 0, comma, negative 57. And since there's nothing added or subtracted in what's getting squared, there's no horizontal shift, my axis of symmetry is actually the y-axis. So my vertex is right there on the y-axis. It's also my y-intercept. My minimum value is choice B right there. It is negative 57. There we go. So they kind of freak you out a little bit with the initially weird kind of setup, but a simple little thing here and knowing a little bit about your quadratics will get the job done. All right, guys, that's about it. So definitely a lot of stuff asked on the SAT regarding your vertex and or like y-intercepts of different functions. So I got another one that's going to also be on exponential functions, and we'll ask different types of questions there, given those guys. So be sure to stick around for that one. I'll be posting that one at some point here, so put those notifications on. That's a smart move right there. If you guys have any questions, pop them in the comments. Suggestions for other videos, pop them in the comments. Just want to say what's up, pop it in the comments. Otherwise, guys, have a great day. Thanks for watching, and stay dope.